Welcome to the 15th episode in creating a third-person controller. If this is your first time seeing this, check the description for the entire playlist. You're definitely going to want to follow from the beginning. In today's lesson, we are going to create a little resource that will allow us to set our movement variables from the inspector. This will make iterating over our character movement a lot easier, especially in this early stage of the project. And it will also make us more consistent when creating levels. A lot of what I cover here is very high level, and if you would like to know more about why I like to use this technique to control my character's speed and acceleration, then I have an entire other series where I cover each of these formulas in much greater detail. Check out the links in the description. The controller is looking pretty good. We've got all of our movement in place. Our state machine is ready to go. We are ready to start adding an animation player and then working on the weapons. But there's just a couple of things that I wanted to do before we move on to that, just sort of as a bit of a cleanup, and it's not entirely necessary. So if you don't feel like you want to do this, you don't have to. But there's something that I always like to do with the way that my characters move and how I calculate that, just to get like more control over it. Because right now we'd have to come into this script and change each variable on its own. It's not in the inspector over here like it could be if it was anything else. And we don't really want to put this as an export variable because you'd need to set it for every single state, which is kind of annoying, right? Since all of these inherit from the same class, then it doesn't really make sense to have them as export variables that need to be set in each of the different states. It's just not a good idea. So I'm going to create a resource that we can use to sort of set that in the state machine here. So there's just one thing that we can go to change the way the player moves, and we'll also change some of these and how they're calculated, because I don't really like to just do speed equals 5. I like to set the jump distance and the time in the air. Rather than saying we're going to go 5 meters per second, that's what that's saying. We're going to say that we can jump 2 meters. And what that allows us to do when you're designing a level, if you want to put a gap in that the player has to jump across, then you automatically know that it needs to be less than 2 meters long. Otherwise, the player won't be able to make it. So that is the advantage of doing things that way. It's a little bit different. I have an entire free course on that across multiple platforms if you want to go check that out. It's really helpful, and I think it's the best way to do things. So that's what I'm going to do here. But once again, you don't necessarily have to follow along if you don't want to. It won't really impact anything else in the course except for these variables, right? So the first thing I'm going to do is on the player, create new script, not resource, and it inherits resource. And it's going to be called movement stats, right? And object empty is fine. We're going to create that, and then we can click in to access that, right? So we have to give it a class name, pretty straightforward. And it's going to be movement stats. Now we need a set of export variables, and we'll go through them one by one. So the first one is the time to jump apex. It's a float, and I'm going to make it equal to 0.5. So this is the amount of time that it takes us to reach the top of the jump, right? So half a second to get to the top. And the next variable is going to be time to land, and that'll be a float as well. And I'm going to make this exactly the same, 0.5. And so you can imagine from these two variables that the amount of time that we spend in a jump is 1 second. So you have two, so you can have a separate jumping gravity and a separate falling gravity, which is helpful to have in terms of just like designing flavor. The next variable is the jump height. Pretty self-explanatory here. This is how high we can jump. Now it's better to define this rather than a jump velocity, because you can very easily determine how high you need to make obstacles in order for your player to jump over. The same way we're going to define jump distance. So that's our next variable here, jump distance. And I might make that something like 4 meters. You can play around with this in the inspector later on. We can get something that works for the scale of the level that you're working in. So the next thing that we need to do is actually define the sprint jump distance, right? Because sprint is a different jumping speed. So we're going to be able to jump a different distance, and I'm going to make it like 7 meters. It's quite far. I don't think a normal person can jump that far, but you know, it's a game. That's fine. And then the final one is the aim jump distance. Now we can't actually jump in our particular set of states. We could. It'd be really easy to set up, right? It's the exact same thing that we did for the sprint. But because of the way that we calculate speed now, it's just going to be easier to define that and then create a function to calculate what the speed would be if we could jump. if that makes sense. We could always do a modifier on just the jump distance, like halve it or something like that. But this works. It's the same result. The next one that we want is acceleration. Now, I know that at the moment, acceleration is just in the function itself, but I'm actually going to pull that out and we'll pass that into our velocity calculation as well. So I'm only going to make it 100 instead of 1,000. Sort of done some testing over the last couple of days. I think that's fine. It doesn't really need to be 1,000. The next variable is in-air acceleration. And the reason we're pulling it out is to add this in, because this will allow us to still check for direction inputs when we're doing the sprint jump. So if we're in the air, we're going to not move as quickly, essentially. The rate and change of our speed will be a lot slower, which means we won't be able to navigate in the air once we're off the ground as fast. So you can make this anything. I'm going to make mine quite low. You could also have two different variables for this. So you could have like sprint in air and regular in air. I'm just going to have the one. Okay, so next is the sprint duration. This is actually not going to be used in any of the jumping calculations. It's just going to be here. Nothing fancy. It's exactly the same. And it's equal to 3 seconds. And then the final variable that we want is actually a new one. And it's going to be called minimum sprint threshold. It's also a float, and we're going to make it equal to 0.5. Now this is going to take the place of the 0.5 here. So essentially what we're saying in this particular block of code, that is, if we've pressed sprint and sprint remaining is less than 0.5, then we can't actually access sprint. So we need to wait until there's at least half a second of sprint in the variable before we can actually activate sprint, which will prevent the player from spamming that. So you could make it as high. You could say like it's 3 seconds, and then you would have to wait until sprint is completely replenished before you could enter sprint again. Something that's worth remembering is that you don't want this to be greater than your sprint duration. Otherwise, you'll never be able to access your sprint. And there's nothing right now in our code to prevent that from happening. So 0.5 is fine. Okay, so we're going to create a couple of different functions to help us calculate the gravity and the velocity. And we're going to be able to just call these in our state machine to figure out those either in the ready function or whenever they're updated or changed, because that's going to be possible as well. All right, so I'm going to create a function called getJumpGravity, and it is actually going to return a float. And we're going to go create a variable here called jumpGravity, and it'll be a float. And what I'll do is I'll just type return jumpGravity. And okay, so the next thing to do will be to actually calculate jump gravity. So how do we do that? So the gravity is going to be 2 times the jump height divided by the power divided by time to jump apex to the power of 2. So we type power because that's how we do powers in Godot, and it's time to jump apex times to the power of 2. Okay, so that's our jump gravity. Let's create one for the fall gravity. Get fall gravity, and it will be a float. And we're going to do pretty much the exact same thing. So this one will be called fall gravity. It'll be a float, and it's going to be equal to 2 times the jump height again. But this time, for this power, we're going to do time to land to the power of 2. And then we can just return the fall gravity. Okay, so now we need to calculate the jump velocity. So we'll create another function here, call it getJumpVelocity. And what we'll actually do for this one is we're going to need to pass in gravity, and it'll be a float, and it'll return a float. Okay, and the reason for this, in order to calculate the jump velocity, we actually need to know the gravity. So how you might do this, right? If for whatever reason the gravity changes, or you need to in the ready function, what we'll do is actually call getJumpGravity, getFallGravity, and know those numbers first. And then before we actually call on this function, pass that final number into this function as well. So we've got calculate jump velocity. And so we need to return a velocity. So var jump velocity is a float. It's going to be equal to gravity multiplied by time to jump apex. And then we can just return that. Okay, so now that we've got jump velocity, we need to get velocity. And this will also require us to pass in different variables, mostly because I don't want to write a separate function for like regular run, sprint, and aim. So rather than doing that, we'll just create a function called get velocity, and it's going to take a distance, which will be a float. And it will also take a jump time, which will be a float. And it's going to return a float, right? And so the velocity, which is a float, will be equal to the distance divided by the jump time. So speed equals distance over time, the classic function from physics class, if you remember it. And then we just return the velocity, right? So those are all the functions that we need. The reason that we are not defining these variables in the resource is because resources can't really hold variables like that. We could, of course, make it an export variable and calculate it. It would probably work then, but then you would also be able to edit that in the inspector, which we don't really want. So it just makes more sense to create functions to do the calculation, but actually keep those variables within the motion class. So you'll see what I mean in a second. Now that we've done this, we can actually go back to the player and just hit save on that. I don't know if I have. And we can actually go back to the player and we can create a resource now. And now we can actually go look for movement stats. And I'll make this one and I'll call it player movement stats. And we'll hit save on that, it's fine. And so what we can do now is in this script for the state machine, we can create an export variable called player movement stats, and we can make it a movement stats type. And then when we click on that, we'll see this empty thing open up here, and we can click that and we can drag it and we can put it over here. So now in the inspector, if you ever need to change a variable, it's all here, right? We don't need to go digging into the script, which is a lot more efficient, I think. Quick reminder, like and subscribe if you're learning something new. Want the full course right now? Join my Patreon or become a channel member to access everything immediately. Prefer to pay once? The complete course is on Udemy with lifetime access. Links in the description. Okay, so now we are ready to go back to the motion. Now we have a lot of variables here, and we are going to need to get rid of some of them, like acceleration and sprint duration. We don't really need anymore, right? But we still need gravity, sprint speed, aim speed, jump velocity. These things still need to exist, but probably not in the same kind of way. So what we can do is just comment these out. We're going to get a lot of errors, but don't worry about that. And we need to create a set of new variables that aren't constants, really. And they're going to be float, speed, obviously. They don't need to have any kind of value either, because we're going to set them in the ready function and then in the enter of the different states. So I'm going to go through and create all of these variables here. You should do the same. Pause the video if you have to. I'm going to do this at a little bit of a faster speed. And then for gravity, we do need two, right? So we need jump gravity and you need fall gravity. And now we're going to get a lot of errors, right? And that's fine. What we also need to do is get access to our player movement stats. Now, we could have our state machine pass that variable onto the various motion scripts here. Or what is actually possible is to just include this as a constant on this script. And that is because resources are unique, meaning that if we change it here and hit save, it's going to be changed when we access it in this line here. Now, it is important that we are working on the same resource. So if you clicked and made this unique, obviously that wouldn't be true anymore. But because this is the same file, like the path to it is the same, you look at that res player movement stats, and that is player movement stats.res. We're working on the same file. So the numbers are going to be the same. So we can edit this in the inspector, save it, and when we access this constant here, it's going to be the same. So now for things like sprint duration, obviously that just becomes player movement stats sprint duration, right? Acceleration, we've removed that. So we'll put a line here, acceleration, at the end of all of this, and it's going to be a float. And you know what? I don't really like delta not being at the end of this. So I'm going to move it. It's going to be a little bit more tedious when we set it up, right? in the various scripts, but I think delta just looks better at the end, let's be honest. And now we just need to replace acceleration with acceleration here. Okay, and we've got gravity, right? So gravity is changing a little bit, isn't it? Because it's going to be between fall and jump gravity. So we need to include both of those. And also, just by nature of the way I'm calculating this, this needs to flip to a negative rather than being a positive. So we can say if velocity dot y is greater than 0, then we're jumping, right? So velocity dot y minus equals jump gravity multiplied by delta. And then we can say else velocity dot y minus equals fall gravity multiplied by delta. So depending on the direction of the velocity of the y, will have a different gravity. So like technically speaking, if you were to put a force on your player that wasn't a jump, this would still calculate as a jump, but there isn't anything in our game that can do that. So it'll just be the jump. Okay. And now we have this sprint duration. So that's the same as before, player movement stats dot sprint duration. All right. So that satisfies all the errors in the motion script. However, every single one of these scripts here in this state machine is going to have errors. So we'll work on that, but we're not done here yet. We need to calculate all of these, right? So this is pretty easy because we set up those functions before. So in the ready function, we can just go speed is equal to player movement stats dot get velocity. Now this requires a distance, right? So we've still got them as constants here, player movement stats dot jump distance, and then it's jump time. So that's going to be both the player movement stats time to jump apex, and I'm going to put a plus there, player movement stats dot time to land. And I might just pop this out so it becomes a little bit easier to read. It's quite a long calculation, mostly due to the fact that this constant is quite long. So if you feel like renaming that, go ahead. I'm not going to. I'll just deal with it. Okay, so the next one in our list is sprint speed, right? And you know what? It's pretty similar to this function call here. The only difference is that the jump distance is going to be the sprint jump distance, right? The time in the air is exactly the same. And the same with aim speed. It's also going to be very similar, but the distance here is the aim jump distance, even though we can't jump when we're aiming. So now we need to calculate the jump gravity and the fall gravity. So they're pretty easy. It's going to be jump gravity equals player movement stats dot get jump gravity. And that doesn't take any variables. So these are all relatively straightforward. Fall gravity is equal to player movement stats dot get fall gravity. Okay, we can calculate jump velocity, and we can also do that in the ready function or in the enter function of the jump state, but we'll do it here as well. I'll just show you how flexible the script can be if it needs to be. So player movement stats dot get jump gravity, get jump velocity, and it wants a gravity, but we only really need to pass it the jump gravity, because if we're finding out the jump velocity, it only matters when we're jumping, right? So we pass it the jump gravity. Okay, so that should satisfy all of our variables here. Now we are still getting a ton of errors, and that's because if you go into each of these, it's going to say that the calculate velocity function is incorrect. And that is because we need to add acceleration. So we can add one here. Just remember that I put it in the order of speed, direction, acceleration, and delta. So we need to change this to just lowercase speed. Unfortunately, we do need to change those because all uppercase does mean a constant, and this isn't constant anymore. It could change, and I'll show you that later. Okay, so we've got speed, direction, and player movement stats dot acceleration. Once again, we could always just like add that and make it a variable within motion and set it to player movement stats dot acceleration, but I think it's just a little bit better if it can be flexible and changing. Okay, so that one is going to be the same in the run. So we can come and replace that calculate velocity function here. Hit save on that. And same for aim idle. We'll just go down all of them. Now this one, we still have to replace this with aim speed, obviously. So it's aim speed, direction, player movement, stance, dot acceleration. None of that changes, then delta. And we can copy that for aim walk. Okay, and then the same for sprint. So we can paste that in here, but this is going to be the lowercase sprint speed. Okay, and so everything's going pretty smoothly. We're just replacing these functions with the new updated functions. We can go to jump. This is where things get a little bit different. We can just replace this with jump velocity. And on top of that, like I said before, this could actually be calculated on the fly. You could go player movement stats, get jump velocity, and then pass in the gravity as well. That works exactly the same. But I'm just going to make it jump velocity. And then for this, we want it to just be speed. And for the player movement stats dot acceleration, this is where, now that we're jumping, we can do in-air acceleration, right? Which is pretty fun. And same for the fall, we come back to this. It's got in-air acceleration. And so now we won't be able to move as quickly when we're in the air. We'll be locked into a direction because we already have forward momentum. So it's actually, we're not going to slow down, but the in-air acceleration will prevent us being able to change directions as we're moving. So that's fall. Now we have sprint jump. So this we can replace with sprint speed. So make that sprint speed. We've still got in-air acceleration, but here we're not getting the direction. So now we can still get the direction. So I can come back in here, because if you remember, I was just deciding not to check direction. I think it's a good example, but now we can actually get that, and we'll just have it move much slower. So now we'll have jump velocity, and for this jump as well. And also remember how I said you could have a third variable here. You could have two different in-air accelerations depending on sprinting or falling. It's entirely up to you. You could add a third variable here. It's really easy at this point to make it there, make the variable, and then bring that change through. Okay. So then finally, I'll just copy this sprint fall, which requires us to give this same information. And then here as well, we can add set direction and probably remove it from this little check here, because now we are getting it there. We don't need to check it before we get into this exit condition. Okay. So that is all of the functions. Let's see if we've done it right. Run this. We've got all the things going. We run, we jump, we run, jump. And if you followed along, you'll see that now when you change directions when you jump, it's much more sluggish. You can still do it, but it won't be as responsive. And to be fair, you might not notice much of a difference, but the whole point of this is to give us flexibility, right? So now if we wanted to make it, and this will affect our speed. Oh, you know what? I actually forgot. In the run, we have got this function, this little variable here. So we can replace that with player movement stats dot minimum sprint threshold. So it's for another very long variable there. Okay, so now we've got that. And now, right, I was going to demonstrate how easy it is to change things. So what if we wanted, we'll keep the speed the same. So if we were, say, if I go to the state machine, if we go to motion and we were to print out, we can remove this as well, these commented out stuff. If we were to print out the speed after we've calculated it, what would it be, do you think? It seems like it's calculating to 4. And that would be because obviously we've got 1 second and we've got jump distance. So in 1 second, we can move 4 meters, right? But if we were to change this to 2, so we made the jump all 2 seconds. Now we're going to be able to move 4 meters in 2 seconds. So we don't need to go as fast. We're actually going to be moving at 2 meters per second, which is really slow. The jump is really slow. It feels like I'm on the moon, maybe. And that's the beauty of this, right? So maybe let's imagine a situation. I'm not going to do it because it would take too long. But imagine a situation where you entered a low gravity environment and you needed to simulate that on your character. And character bodies they can't respond to physics stimulation. You need to define it yourself. With this system, you could easily trigger either a new player movement stats sheet and replace this, and then run those updates, right? These functions here. You can even call these in the run. So you could go in enter, you could say speed is equal to player movement stats dot get velocity, and then pass in your distance and jump time, and then it would always be updated when you enter. Now I haven't done that because, to be frank, I'm kind of lazy. It's a better way to do it. But it's just a matter of being aware of the kind of game you're making. So if that was a possibility to be able to change them, not that you would replace the sheet, like I said before, because this is a constant, but you get the point that I'm trying to make. You can update this on the fly, and you can also change it very easily. So we just changed that to 0.1. What if I wanted to make it so a slow up and a fast descent? So this will make the jump part actually pretty slow, and then the landing part really quickly. But we'll actually move at the same speed that we did before. So you'll see that it calculates it to 4 meters per second. The jump will be very slow up and then fast down. Design choice. I actually like to keep mine at like 0.6 and 0.4. Very slight difference. The aim speed is going to be a lot slower than it was before, I think. But I think that's okay, you know? All right, so that is it. We're ready to move on to adding the animations and starting to get really close to being done with this controller. We got the animations and then obviously the weapons. So we'll see you there. All right, guys, that is all for this episode, and that concludes creating our state machine. Next week, we're finally going to be bringing in a rig and character animations to attach to this third-person controller. If you're finding this series helpful, don't forget to like and subscribe. It really helps the channel out. And if you want to get access to every single episode in this course immediately, then you can become a channel member, or you can join on the Patreon. And if you want to buy the course outright, you can do so over on Udemy. All right, that's all for this week. I'll see you guys next time.